Okay, everybody, just in relation to setting out a string for a straight flight of stairs, first thing you'll have to do is you're going to have to mark out what's called a pitch board. Any square piece of timber at all, maybe 2 foot by 1.5 foot. Measure up the rise one corner as shown here, and measure up the going measured here, and there's your pitch. Then that will be the angle of the stairs there. This is called the margin line. That's just the hypotenuse between the rise and going. The length of that line determines how much actually you'll shift the router template or router jig later on, which I'll explain here now. To get the pitch, we'll be using the formula that we had on this animation, and just to illustrate that on this calculator here, just make sure you're on degree mode. So you'll see a little D logo right here at the top. Just right there, there's a little D. Make sure that means you're in degree mode. If not, you have to press the mode button, and the mode button will give you different numbers on the screen that will give you the degree mode. So I am in degree mode there. So again, we can take an example of again the rise is 200 and the going for the step is 250. So we want to check the pitch of that. So using the formula, you'll be taking the rise as being 200. So it's the rise, 200, divided by the going, which is 250, hit equals, and you'll just hit the shift button up here, shift, hit 10, and hit equals, and this gives you the pitch of your stairs right there. So that tells you that it's a 38.65 degree stairs. So it's for a private stairs, it's below the 42 degree max that you can have. Okay, the message from this slide here basically is making the point that once you have your rise and going marked on your template, if you measure the diagonal between the rise and going, which is the hypotenuse of a right angle triangle, that is the distance you'll be moving the template each time along the stair string when you're routing it. So you can physically measure it from here to here, but if you want to be more accurate, this is the formula you'll be using, and whatever your answer is, that'll be your answer you'll get. Don't forget that's squared, so you'll still have to get the square root then of the answer to find out what that distance is. So we're going into that now here. I'm just made a little video here using the scientific calculator. Okay, so to get the hypotenuse between the rise and the going, we'll be using Pythagoras' theorem, which, as you might recall, is a squared plus b squared equals c squared. And of course the C is always the hypotenuse, which is the longer line of a right angle triangle. So in our case, we're looking for the hypotenuse between the rise and the going of the step. So we'll take an example. In this case, our rise, we'll take it as being 200. So we'll go 200, this button to square it, hit plus, and then we'll take the going as being 250. So we'll go 250, hit squared to square it, the x with the little 2, and hit equals. And whatever your answer is, you got to get the square root of that to find your hypotenuse. Obviously that distance is way too big. There's no way the hypotenuse could be that distance. So you hit the square root sign, hit the answer button, and don't forget to hit equals. And there you are. That is the hypotenuse between the rise and going of your step, and that's how much you'll have to shift your stair jig template every time up along the string as you router each step. Okay. So here are some regulations you need to bear in mind. One is the rise distance must not be greater than 220, the going distance must not be less than 220, maximum pitch 42 degrees. There's a formula there, twice the rise plus the going must be between 550 and 700. Maximum number of rises is 16 per straight flight. So now that we're have our pitch board is marked out, we need to start thinking of actually marking it on, transferring it all onto the string. So the following animation will illustrate what's required as shown here in text. So the margin line is located where the rise line and going line meet near the top edge of the string. And that's going to be illustrated here now, this animation. And this is the line that the rise and going is measured off when you're setting out the stairs. So this animation just explains to you what it is we're looking for when we're talking about the margin distance or margin line. It's that distance from the top edge of the string down to where the rise and going of the step meets each other. And that will ensure then that when the stairs goes together, that the bottom edge of the riser will line up with the bottom edge of the string when the stairs is complete. So there your margin line drawn there now in white, and here's your going line marked, and there's your rise distance marked off the margin line as well, and of course the two of them are 90 degrees to each other, the rise and going. So that's why you're using a square piece of timber or whatever. The margin board you used earlier on was square. And here's just an outline of the step itself, and see how that relates. Note how that relates to the rise and going line we drew. You know, the rise and going line basically represents the surfaces that you'll see when the stairs are together when you're walking up the stairs. So sometimes when people are setting out the stairs or drawing a section through the stairs, they're not too sure which side of the going line or the rise line to put on the thickness of the actual piece of timber themselves, that being the thread and riser. So it's illustrated here, you know, so just bear that in mind. So this is going to show you here how to find the margin distance on the stair string. So first of all, you're going to bring the pitch board that you marked earlier into play here now. So the hypotenuse line there where I've written shift distance, that lines up at the top edge of the string at the moment. So then we get two thicknesses of the actual piece of timber that's going to the one's going to form the thickness of the riser, and the other piece, these are offcuts you can get. Your typical thread thickness is usually 25 mil, and the riser would be less, might be, you know, something like 18 to 20 mil or thereabouts. And currently, as you look at them, the corner here is not in line with the bottom edge of the string. You know, there's a gap there, and you don't want that gap. But so all these will have to be pushed down until they're lining up with the bottom of the string, which is now going to be illustrated here. So that is the actual margin distance there with the double-ended red arrow. So that needs to go for that's going to be transferred to the other side of the string. Really, that's where we need it. So. And that same distance is going to get marked onto your pitch board that you marked earlier. So now you have two lines on your pitch board. That second line now will represent the top edge of the string of your stairs. So you'll see the pitch board move now. So both this line and this line now will line up with each other. So this is when you can see there they line up here now. The step goes together. Yeah. So now you can just mark your pencil line as illustrated here. There's your rise line marked, and you know they're at 90 degrees to each other because the plywood is 90 degrees to each other, that pitchboard or plywood. Yeah. Now just mark a second line. So once we have these 3 lines, that's enough. We don't need to mark any more lines. We now have enough to set up our jig to. We need those lines there to align the jig off. You know. Yeah. And of course there's a distance between the cutter and the guide that you have to be aware of. And so you'd run it off on a sample piece of timber first to see what is that distance. So then you put your 2x1 laths or something similar just to hold that position then and hold that angle. And obviously this jig will do for any angle of stairs, regardless of what the rise of going is. Remember that always. Some people might think that you have to make a separate jig for separate stairs. No, you don't. No, it's just the tilt of the jig that changes. And when you're routering out now, remember, you're going to have to start here, and because the way the bit is rotating on the router, you're going to have to start here, and because the bit is routing this way, it'll want to pull into this shoulder here because of the clockwise rotation of the cutter. So you'll have to go up this way, up along here first with the router. So you're going up along the going line, you're just cleaning along the going line. You're going to go in around the nosing, and you're going to be going across the top here first. And you're going you're going clockwise around the template. You'll be around here again, and you're going to come back around here. So the router is going to be hugging this line then as it's coming down, because as the cutter is turning, it's making you hug it. You have to hug it in. And just while I'm here, just remember when you're unplunging the router, either unplunge it here or unplunge it there. You know, otherwise if you unplunge it up around here somewhere and the cutter happens to hit the router jig, then you've damaged the jig. So you don't want that, and you also want to unplunge the router and lock it for your own safety as well. So there you can see, and what's been removed there with a kind of a timber colour is 1/2 inch deep. If you can visualize that, that's 1/2 inch deep, 13 mil thereabouts. Yeah, 13 mil. Well, 13 mil is minimum requirement. Yeah. Yeah, this is making the point here that you know, before when you router out your first step, this is your floor line down here, shall we say. Just put a little mark right there. So when you shift the template up later on, that mark then should line up with the next level up, which is the next rise distance up, which is the next thread line up, which should be here, that line there. So that's the point that's being made here. So if for some reason one of your shift distance marks was marked wrong up along the bottom edge of the string, at least this would be a double check, a safe. Just you'd know if that didn't line up here that something's wrong. You know, so it's a good way, because you don't want to router a whole string and find out that one of the steps is wrong. You've used a lot of material, a lot of time, and so yeah. So you need to have that little extra cross check measure there for yourself, just to be doubly sure. So now we're ready to slide the jig in for the next step. So we move it up the shift distance, as stated before. That's the hypotenuse between the rise and going, and that's the distance. You'll see that moved here now. So there you go. And now we're all set. And there's the alignment point, just to confirm that we have shifted the correct distance, that we haven't made a mistake. So that's very important, yeah. Yeah, here we have to, now we're ready to router the opposite string. So now we have to make sure we remember that the strings are handed There's a left hand and there's a right hand string. So when I use the word ascending, so as you're going up or as you are ascending the stairs, the string that was on your left, we've currently, the jig is currently set up for. But now it's going to have to be reversed. So it's set up for the right string as you're ascending or going up the stairs. So that will mean that these lats will now have to be transferred onto this side of the jig. And that's something you got to be very careful that you're very accurate about. Sometimes people will use 2 extra lats and screw them on so they know the edges of this one and the edge of the new one are square to each other. Or you can just mark here, but be precise, because you don't want to change the riser going if you can at all when you're swapping that lats, and it could easily happen. So be careful. So be very precise when you're doing this operation. So as stated, there we are. We're just marking the position of those lats. And now we're going to transfer the lats now onto this side, so it's ready for the opposite jig, the opposite string, I should say. So so now we're on the opposite side, and now we can screw it in now here again, and we're safe to do the opposite string. Here we're marking the opposite string off the first string that we did, so there won't be as many marks now on the second string. The only marks you need are these marks here, the shift marks. And them shift marks will be all the way up the string, and they'll be the same distance. And so you just bring the other string into it, bottom edge to bottom edge of string, transfer the line across. That's the only line you need, and because that's where you'll be moving the jig to. In this case, just a few final tips here, lads. Yeah, just making the point here that if you start your router at the bottom of the left string going upwards or ascending, you won't chip off the inner corner between the riser and the going where they meet, because that happens because of the way the bit is turning on the router. The other point I'm making here is unplug and lock. Yeah, as you were shown before, yeah, unplunge and lock before you lift away the router, so as it can't plunge again accidentally. Make sure you lock it. And here, the point I made earlier, only lift the router off where you know if you damage it, it won't be up where the thread and riser will be meeting the string. So the best place is always as far as near to the bottom edge of the string as possible, or the best place to take away the router if you're lifting it off the jig. But you should have it unplunged before you lift it off anyway. But yeah, and of course here you can wear a visor or safety glasses and the usual PP with it, but you'll also need vacuum system of some sort, or an extraction system, because there's a lot of shavings here, so it'll clog up very quickly if you're not set up. And of course you need a small router is not good enough for this type of job, so it's the heavier, larger duty router. I think it's 3000 watt. Of course the last point there is, yeah, look, if you're an apprentice, yeah, you should always have someone supervising you or monitoring you, because you're still not there's still hazards you might need to be aware of yet, and there's some hazards that probably not outlined here. So at least if you have a qualified person with you, you're less likely to have an accident. Okay.